Here we go. 2.15. Talking about the Pythagorean theorem. So it says for each rectangle here, draw a diagonal and estimate its length as accurately as possible. So here's what I want to do. Just drawing diagonals here. Okay, I'm going to go from left to right, left to right, left to right. All right, so I'm going to pause now and draw some diagonals in. All right, so those are my terribly drawn diagonals there. Okay, instead of describing the relationship between the lengths of the sides and the diagonals of the rectangle, and the length of its diagonal, I mean I have a hard time guesstimating how long these are, but I can tell you this, that it looks like each diagonal is longer than the length of the sides, which makes sense to me. I'm going to write that out here. I'll type it out for you since my handwriting's not great today. Each diagonal is longer than sides of the shape. What else can you say about it? No, not a whole lot else. I mean, maybe like the sum, which means addition, the sum of the sides is greater than the diagonal. I don't know. There's a lot of things you can say. A lot of things we can say about this. All right. But today's, the reason we're doing this is because today's lesson is about the Pythagorean theorem. Okay. So what we're going to try to discover when can we use the Pythagorean theorem, and is it more difficult to solve for the hypotenuse or one of the legs of a right triangle? And we'll talk about that as we go along. So you've all seen the Pythagorean theorem before. This is what it actually means, okay, using words. All right, this is the mathematical representation. A squared plus b squared equals c squared, or how hypotenuse is always c, and a and b are really interchangeable, okay? Doesn't matter which side you call A, doesn't matter which side you call B, but it does matter which side you call the hypotenuse, because the hypotenuse is always our C, and every time it's always leg squared plus leg squared equals the hypotenuse squared. Here's a little bit of an example, but we'll get to that in a little bit here. So this is an example of a word problem here. It's kind of interesting to think about, okay? I want you to read through it. It says at John's school, and go ahead and read through it. So essentially it's saying, hey, the straightest, the shortest distance between two lines, or between 2 points is a straight line. Okay. If I want to think about how far he's traveling diagonal, I want to use the Pythagorean theorem. Okay. Where a squared plus b squared equals c squared, or in this case, the diagonal path they use for the letter D. Okay. Yada, yada, yada. To get rid of a squared term, we take the square root, don't forget that. And then they just gave you a rough estimate, about 626.8 feet. So this is the distance here. How much time is it saved by cutting across? All right, so here's what I want to think about, or what the book does a good job of explaining. Well, it's important to think about how much distance he's walking if he didn't take the straight line path. Okay, would have walked 870 feet. So really he's saving 243 feet. Now, in the grand scheme of things, it says that he saved about a minute and a half, but that could matter if you're in a rush to get somewhere, if you're in a rush to get to class, if you're in a rush to get to work, if you're in a rush to get to an appointment. A minute and a half can make a difference. Okay, so remembering that. He does this whole thing. Remember this, you may have seen this before, distance equals rate times time. So then time, if I divide by R, that's where they get time, is distance over rate. Okay. Not entirely important to this section. It's just kind of tying in something that you may, you could actually do this. I know you won't sit there and calculate, get your calculator out on your phone and calculate the straight line distance and how much time you might say. Hey, you never know. I can have wishful thinking, but we're going to keep going. All right, so then the book gives you this long explanation about how it works. All right, I'm not going to talk through the how it works portion. I believe, well, not that I believe, I hope at some point in your mathematical careers you have seen the Pythagorean theorem before. Okay, so I want to talk about this. Whenever you see a word problem like this, says find the length of the hypotenuse if the legs of a right triangle measure 10 feet. So I'm just going to draw in a picture and I know it looks like that, and I'm looking for C. Okay? Well, A squared plus B squared equals C squared. So my legs are both 10, so A and B are both 10. I know that 10 squared is 100. So C squared equals 200. Now, I can do this two ways. All right, I'm going to square root both sides. I can think about C equaling is the square root of 200, which if I want to simplify that radical, it's 100 times 2, which is 10 root 2. All right, now we haven't done that before in this class. We've done that in the past, but I just wanted to remind you that it is a thing. What I would just do is figure out what the square root of 200 is. 200 is just is about 14.14 feet. Okay. This is, I mean, I just showed you this just to remind you that that is a thing. Okay. Remembering that rationalizing, simplifying radicals is a thing. Let's try this one. Find the length of the legs of a right triangle. If the legs are the same length, then the hypotenuse measures 10 feet. So now I have x squared plus x squared equals 10 squared, or 2x squared equals 100. Okay, x squared plus x squared, just like x plus x is 2x squared. I need to divide by 2 to get x squared equals 50, and then square root both sides. Now again, I'm going to show you the simplified radical form just because it's fun for me and for you, for everyone. That's 25 and 2. Where does 25 come from? Where does 100 come from? I think about the perfect squares and multiply into the radical. All right. So that means x is 5 root 2, because the square root of 25 is 5. Let's see what that is. It's 7.07 feet. There you go. There's part B for you in number 2. Sorry, it kind of came together there, but let's keep going. Let's talk about Pythagorean triples. So here's the deal. Pythagorean triples, it says they're always listed in increasing order. Sometimes they're not going to be. All right, I'm not going to lie to you. Sometimes they're not going to be. But C equals the largest number. Okay? There's a lot of Pythagorean triples out there. All right? 3, 4, 5 is a Pythagorean triple. So 3, 4, 5. What Pythagorean triples are, they're perfect numbers where if I multiply, if I use the Pythagorean theorem here, it ends up working. And any multiple of these numbers checks out. Okay. In order to test to see if something is a right triangle, the Pythagorean theorem has to work. Say it again. In order for anything to be a right triangle, the Pythagorean theorem has to work. And I believe they said that in one of these boxes here, but I want to reiterate that. Okay. Yeah, it was in the beginning box. All right. Back here and here. Okay. A right triangle. In a right triangle, this is always going to be true. All right. So this forms a right triangle. If a squared plus b squared equals c squared, then there's a right triangle. If not, then obviously it's not a right triangle. Okay, that would be true. If it's not, then if not, then it's not a right triangle. If not, then it's not. All right, excuse me, sorry. I'm getting my emails. 1 second. All right. Anyway, so we're talking about Pythagorean triples here. Okay, so we want to use Pythagorean theorem to complete the following triples: 3, 4, 5. Okay, 6. What's the relationship between 6 and 3? Well, from 3 to 6, I multiply by 2. From 4 to 8, I multiply by 2. So from 5 this number, I'm going to multiply by 2, so that's 10. Now, let's say I didn't know that. Okay, let's say I didn't recognize that. Well, I would do 6 squared. I would do 6 squared plus 8 squared equals c squared. I would keep going. 9 squared plus 12 squared equals c squared. But I can see a relationship between 9, the 3, and the 9. 3 times 3 gives me 9. 4 times 3 gives me 12. 5 times 3 is 15. Okay. 3 times what number gives me 30? 10. 4 times 10 gives me 40. 5 times 10 gives me 50. Again, I could do 30 squared plus 40 squared equals c squared. Okay. 57 divided by 3. Is that a number? Yeah, it is. I think it's 19. Yeah, it's 19. So 4 times 19 is 76. 5 times 19 is 95. We're kind of getting the hang of this. 60 divided by 3 is 20. 20 times 4 is 80. 20 times 5 is 100. All right. So what question asks, what relationship do you see between the first and the second triples, between the first and the third, et cetera, et cetera? Well, I kind of explained it as we went along. The first and the second, it's just double. We're doubling our triple. The first and the third, I'm tripling the numbers. Okay. So for this one here, it's the triple times 2. I'm going to type that out for you. Okay. For this one here, the triple times 3. And that's it. Okay. And we could keep going. For this one there, it's a triple times 10, times 19, times 20. Now, obviously, I'm not going to ask you to memorize, all of these numbers. Okay. You may not even have to memorize 3, 4, 5. I just know that in my head because it's an easy set of numbers. Okay? However, it does make your life easier, but you can always use the Pythagorean theorem. So if I just confuse the heck out of you by talking about it by times 10, times 19, use the Pythagorean theorem. 3 squared plus 4 squared equals c squared. 6 squared plus 8 squared equals c squared. Okay? It's an easier way to do it. All right? We're going to stop here, and then we'll pick up here in class.